Everybody. Today we are talking about lesson 5-6, and we will be discussing the distributive property. This is on page 305 from your workbooks. So the distributive property is one of the properties of mathematics that we use to help us solve expressions. So let's jump into our book. All right, so the distributive property, there we go, states that to multiply a sum by a number, we multiply each term inside the parentheses by the number outside the parentheses. So if we were given a problem like this, right, you have a number outside the parentheses and two numbers inside the parentheses, it would be the same as doing 2 times 5 plus 2 times 6. You distribute the 2 into both terms inside the parentheses. If we represented it with variables, it would mean the exact same thing. We distribute whatever is outside into both terms inside. All right, so let's go ahead and practice a couple of these. Let me try to adjust a bit here. All right, so if you are given a problem like this, A times B plus C, it would be the same as A times B plus A times C. So we could rewrite this expression as AB plus AC. Now, if we have actual numbers here, right, we would do the same thing. Like I said, you distribute the outside number into both of the terms inside the parentheses. So this would mean the same as 2 times 3 plus 2 times 5. 2 times 3 is 6, 2 times 5 is 10. So then we would do 6 plus 10, and the answer then would be 16. What if we had an expression like this? Here we have one variable. Remember, we distribute it into both terms inside the parentheses. So 3 times x is 3x, 3 times 4 is 12. So the solution to this expression would be 3x plus 12. So let's take a look at an example. So here we have example 1. We're going to use the distributive property to expand 2 times x plus 3. So we're rewriting it as a new expression. So what we do, remember, is we distribute that 2 that is outside into both terms inside. You have to do both, okay? When you do that, you end up with 2x plus 2 times 3. So 2x plus 6 would be the correct answer here. All right, let's try the check. So remember, we distribute the 8 into both terms inside the parentheses. So pause here, write down your answer. So if you were to do this, it would be 8 times x plus 8 times 3. So this would be 8x plus 24 would be your correct answer here. All right, so let's use this distributive property to find 8 times 3 1/2. Now, the distributive property is really great when we're working with problems with mixed numbers, because what it says is we can break 3 1/2 into 3 plus 1/2. This allows us to use mental math to solve multiplication problems using mixed numbers. So like I said, we're going to break 3 1/2 into 3 plus 1/2. We can then do 8 times 3 plus 8 times 1/2. 8 times 3 is 24. 8 times 1/2 is 4 because it's the same as dividing by 2. 24 plus 4 is then 28. So our answer here would be 28. So let's do the same thing with our check. You're going to pause here. You're going to break 2 1/4 and do 2 plus 1/4 and multiply that by 12. So pause here and solve. So if you were to do this, it would be 12 times 2 plus 12 times 1/4. Remember, multiplying by a fraction is the same as dividing by the denominator. So 12 times 2 is 24. 12 times 1/4 is the same as 12 divided by 4, which is 3. So 24 plus 3 is then 27 would be our solution to this problem here. So let's talk about greatest common factor and the distributive property. The same way that we were able to condense our problem using the distributive property, we can then take out common factors. So we can use the greatest common factor to rewrite the sum of two whole numbers with a common factor as a product. The distributive property allows you to write the sum as the product of the greatest common factor and the sum of the remaining factors. When numerical or algebraic expressions are written as a product of their factors, the process is called factoring the expression. To factor an expression, we follow these steps. The first step is to find the GCF of the terms. We then write the terms as a product of factors and rewrite the expression as the product of two terms. Now that sounds like a lot of mumbo jumbo, I know. So let's actually explore it in terms of how it would work. So say we have the problem 8 plus 56. I want to factor the expression here, which means I need to first find the GCF of 8 and 56. Now, we would know that 8 and 56 have a common factor, a greatest common factor of 8. So what I would do is I would pull 8 out, and I would put 8 outside my parentheses. Well, 8 times what is 8? That would be a 1. 8 times what is 56? That would be 7. So we would have inside our parentheses 1 plus 7. So 8 times 1 plus 7, okay, would be how we would rewrite that expression. All right, so let's go ahead and try that with this problem here. So what we would first do is say, what is a common factor of 45 and 6? Obviously, the x we can't really use, okay? So we would look at just the coefficient 45. 45 and 6, they have the greatest common factor of 3. So we would pull 3 out and then do 3 times 15x plus 3 times 2x, because 45 divided by 3 is 15. 6 divided by 3 is 2. So then we would have the parentheses, right, when we finish factoring the expression, 3 times, in parentheses, 15x plus 2. All right, so let's keep moving here. Let's look at example 3. 45 plus 72. So first things first, we find the greatest common factor of 45 and 72. 45 and 72 have the greatest common factor of 9. Okay. Remember, you can use your t-charts to find the greatest common factors. 1 and 45, 3 and 15. Let's see, can't do 4, can do 5 and 9, can't do 6, can't do 7, can't do 8. So there we go. Same thing with 72, 1, 72, 2 and 36, 3, and let's see, that would be 24. Okay, 4 here. Okay, 5, 6, 7, 8, 9, right? So 9 times 8, right? So we would know that our greatest common factor here would then be 9. So that's what we pull out. 9 times 5, right, is 45. 9 times 8 is 72. So we put the 9 on the outside of the parentheses and have 5 plus 8. So when we factored this problem, we would have 9 times 5 plus 8. Let's do the same thing with 80 and 56. Remember, start by making your t-chart greatest common factors of 80 and 56. That T helps us to organize our thoughts. Okay, so go ahead and pause here, and you will come up with the greatest common factor and factor this expression. Now, 1 and 80, 2 and 40, 3, 4 and 20, 5 and 16, 6, no, 7, no, 8 and 10, right? Okay, 56, same kind of thing. 1, 56, 2, 23, 3, no, 4, no, 5, no, 6, no, 7, no, yes, and 8. So the greatest common factor here would be 8. Put that outside my parentheses. 8 times what is 80? That would be 10. 8 times what is 56? That would be 7. So the correct answer here would be 8 times 10 plus 7. All right. Now let's try this using a variable. Remember, when we have variables here, we only need the numbers. Okay, so the coefficient and the constant. The greatest common factor of 6 and 15 is a 3. So 6 divided by 3 would be 2, so we would have 2x. 15 divided by 3 is 5, so our factored expression would be 3 times 2x plus 5. All right, here we have 36 and 30. So what we would need to do here first is find the greatest common factor of 36 and 30. Go ahead and pause here. Come up with your greatest common factor, and we will check this together. So the greatest common factor of 36 and 30 is a 6. 36 divided by 6 is 6, so we have 6x. 30 divided by 6 is 5, so our correct answer here would be 6 times 6x plus 5. All right, moving on to our apply problem. As always, please give this a shot. Email me your answer, and I'll let you know if you got it right. When is buying bottles of apple juice and wants to mentally calculate how much they will cost? He buys 5 bottles of juice at $2.15 each. Use mental math and the distributive property to determine how much change he will receive from $20. So we have 5 bottles at $2.15 each. Okay, so we're going to use the distributive property to solve this problem, and then figure out how much change you will receive from $20. Here's your hint. You can break $2.15 up to 2 and 15 cents. Okay. All right, folks. That's it for today's lesson. Please make sure to try the apply problem and email me your answer so that I can see how you did. If you have any questions, please let me know, and have a great day.